Okay, so we are on our last topic for this year, and it's called integration. Right now, the title is Antiderivatives and the Indefinite Integral. We'll go back and kind of dissect those words, but just in general, when you're studying any calc course for your first year, it could be split into sections of three. The first section being the study of limits, the second, the study of derivatives, and the third, integration. So I'm really happy that we're getting to the last section where at least it's introduced for you, and next year it will be a smoother transition. Okay, so when we talk about a derivative, you're comfortable with that. If I have f of x and I take the derivative of f of x, it becomes f prime of x. And if I take the derivative of f prime of x, that becomes f double prime of x. Okay, so this we talked about before. I call this the function q. The original function is f of x. Then this becomes f prime of x. And as you see, when I take the derivative, I'm working my way down that function q. Okay? Well, when I talk about the antiderivative, this definition given to you is straight out of a textbook. And I like to do that because it's important for you to understand how to interpret these definitions. You will be reading certain vocabulary and definitions on your own in college and next year. So here we go. A function f is an antiderivative of a function f if for every x in the domain of f, it follows that the derivative of the big F is equal to f of x. So this is super wordy. So what they're just saying is f is the antiderivative. Antiderivative is undoing a derivative. So if I tell you here I'm at f of x and I want to create the antiderivative, which is also the process of integration, I'm going up that function q. So then that becomes a big F of x. That's what this is saying. Now, if we're given a derivative, we're looking at it as we have f prime of x. And if I go up the function q, I'm going to get to f of x. If I take the second derivative and integrate it once, I get to f prime of x. If I integrate it again, I'm at f of x. So integration, which is the process of finding the antiderivative, yep, let me write it sideways here. Integration is when you go up that function q. The derivative is when you go down that function q. So here, the thing that gets funky is that we didn't have a prime. We were given f of x, but now if I integrate f of x, it's like I'm here. If I integrate, I go, well, this was the original function. They're saying, no, there's another function ahead. Okay, so just remember when you take a derivative, you're decreasing the degree by 1. So guess what? When you're integrating, you're going to be increasing the degree by 1. But we will study that. So just back to this definition, because the definition can be definitely a little complicated to understand. If I'm at f of x and I find the antiderivative, then this would be the antiderivative, the capital letter f of x. And what they're saying is that if I take the derivative of f prime of x, well, that's equal to f of x. That's what this line is saying, and that's what they're saying. Yes, if I go down, I'm now at f of x. Okay, so now let's start thinking about what the antiderivative process would look like. If they're telling me, hey, f prime, let me just do this in a better color for you to see. If I'm telling you f prime of x is equal to 2, okay, and I want to know what f of x is. What could have been the original? Well, think about it. This is a constant, correct? It's a constant function. I have no variable with it. If I increase this by a degree, it's going to be linear. So if I looked at this, I said, well, could it be that the original function's 2x? Well, I go, well, I don't know. You're really good at taking the derivative. You take the exponent and you go ahead and multiply it with the coefficient, and then we drop this by 1. So if I do 1 times 2 and drop this by 1, I do get this. So f of x for this problem could be 2x. But then I have to think about that. is that the only possibility? And you might be saying, yeah, that might be it. I said, well, what if I had f of x is equal to 2x plus, let's put 3 there. Why am I doing that? Well, if I take the derivative of this, I still get 2. How come? Because the plus 3, the derivative of a constant, goes away. So this could have multiple possibilities. F of x could be 2x, and I could say minus 5, or f of x could be 2x plus 100. So what I'm really saying is that f of x is 2x plus some constant. Okay, that's really what I would consider my general solution to this. Your general solution. Okay, so I'm only going to try the next one, and this one's a little bit harder, okay, when I'm thinking about g prime of x. So if they're telling me g prime of x is equal to 3x squared, now I start thinking, and I go, how do I get to the next possibility? And some of you guys are pretty clever and can figure it out. It's almost like a puzzle. And I'm thinking that, hey, maybe it could be that I know it drops down by a degree, so it was x cubed. And then I go, okay, but if I drop down by 3, remember that 3 goes in front, and drop this down by 1, that x cubed, it does become 3x squared. So again, this is kind of like a puzzle that I'm figuring out, and I can say that this is plus c. But there's got to be a more concrete way of coming up with the solution. So we're going to get there, but I just want your wheels to be turning on that. So before we do that, I first want to go through all the notation involved in integration. Okay, so here, when I'm looking at this, it says the anti-differentiation process is called integration. Okay, sorry, my highlighter just made that darker. Integration is the process of taking a derivative and going back to the original function, or going up that function q. What you really need to know is different vocabulary. When I look at this, what looks almost like a weird S, that's the integral sign. So when I say integral sign or draw the integral, I'm asking you to draw that long. It looks like kind of like an S, just you go like that. All right, then if I look at this information is saying the indefinite integral. Why is it indefinite? What does this mean? Okay, this right here is the integral sign. This piece here, what f of x, whatever's inside, that's called the integrand. And that's why I kind of liked saying logorand, because we knew that was what we were taking the log of. Well, what are we taking the integral of? That's actually called the integrand. Okay, dx, that is your variable of integration. That's very important to pay attention to. Okay, so what they're saying is that when I go ahead and integrate f of x, the original function becomes the capital F of x, and that dx, well, that dx tells that variable of integration, when it's an indefinite integral, you're going to include that it becomes plus some constant. It's indefinite because right here on the top of the integrals, there are what we call no numbers here. If I had b and a of f of x, that's not indefinite, that's called a definite integral. These values, if you actually have numbers there, are called bounds. When you have just the integral sign with nothing there, that's called an indefinite integral, okay? And so this is all vocabulary that's important. Integral sign, this is the integrand, and dx is the variable of integration, would be x. If it was dy, the variable of integration would be y. If it's dt, the variable of integration is t. So that's going to play a role when we start actually integrating. And when I'm saying integrating, I am going to be taking the antiderivative of the given function. Okay, so let's talk about, before I want to talk about taking the antiderivative, I want to talk about taking the derivative. So if I go ahead and look at this, if I'm here and I have, you know what the process is for us to take the derivative. F of x is equal to a x to the n plus c. You know when I take the derivative that n comes in front. So I multiply, my first step is to multiply the exponent with the coefficient, right? You know that's our first step. That's why I get a sub n. A n x. And then what's my next step is to subtract the exponent by 1. Okay. And that's why I end up getting this. And then you know that the derivative of a constant is just 0. So now, antiderivative, we're going to work backwards. So this was my last step. It's going to be my first step in an antiderivative. What's the opposite of subtracting the exponent by 1? You should be saying add 1 to the exponent. That's the opposite, correct? What's the next step? It says multiply the exponent with the coefficient. Well, instead of multiplying, what are we going to do? We're going to divide the coefficient by the new exponent. Okay, that is the antiderivative process. So if I gave you f of x is equal to a x n plus c, and I want to know the antiderivative, meaning the original function. So f of x would be here on my function q, and this would be above it. I'm going up that function q. Well, what's my first step? Add 1 to the exponent. So I'm adding 1 to the exponent. So I get ax to the n plus 1. And then my next step, now I'm just going to integrate the first term. Then the next step is to divide the coefficient by the new exponent. Well, my new exponent here is n plus 1. And then if I wanted to, I could go ahead and say, okay, c is a constant. What's the variable of integration here? It's x. So now think about it. If you have a constant and I want to add 1 to it, that's the same thing as this constant having an exponent of 0. So when I add 1 to that, it becomes x to the first, and then I divide by the new exponent, it's just 1. So therefore, f of x is equal to a x to the n plus 1 over n plus 1 plus cx. Really important. You know, hey, in derivatives, when I take the derivative of a constant, you know that that is just equal to 0. Well, here, showing you here, if I integrate a constant, right? If I integrate a constant, you are now going to get the constant with the variable of integration to the first power. All right, and we will do more practice of that. I'm just going to pause and make sure that you understand this piece for right now.